Okay, lesson 123, page 348, polygons and congruence. If you look at page 348, it says, in mathematics, we call a flat surface a plane. A geometric figure drawn on a flat surface is called a planar figure. We remember that all mathematical lines are straight lines that have no ends. A part of a mathematical line is called a line segment. A polygon is a closed planar geometric figure whose sides are line segments. If a polygon has an indentation, a cave, it is called a concave polygon. If it does not have an indentation, it is called a convex polygon. Any 2 points in a convex polygon can be connected by a line that does not cross the boundary of the polygon. All right, so if you look at these figures here, we're going to determine whether or not these are polygons, and if they are they concave or are they convex? All right, so if we look at this one here, a polygon is a closed figure on a plane, okay? We have a flat surface. This figure is closed, but it is made up of straight mathematical lines, okay? So this would not be a polygon because here we have a curved line. So A, not a polygon. For B, this shape is not closed. There's an opening here. So this is not a polygon. All right, C, closed, all straight lines. So this is a polygon. D, enclosed, all straight lines. This is also a polygon. So for our two polygons, is this one here convex or concave? Okay, so if you can draw a line going from one side of the polygon to another, and you are going outside of the enclosed area, then it's going to be concave. So you can do that on this one. I'm drawing a line from a line segment from one side to the other, and I'm crossing part of the plane that is not the enclosed polygon. So you have a concave polygon here. Because just think about it as there is a little cave that you could go in here, and you could make your way into that cave, all right? This one would be convex, because any line I draw going from one side to the other, I'm not going to be crossing across open terrain to do that. So this one would be convex. Okay? Now, there are different kinds of polygons with different numbers of sides. Okay, so most of these, regular polygons, we need to talk about those. Okay, a regular polygon is a polygon in which all of the sides are the same length. Okay, if you look at the bottom of page 348, if all angles in a convex polygon have equal measures and all sides have equal lengths, the polygon is a regular polygon. Okay, so an example of this would be a square. It's convex. All of the angles are the same. All of the sides are the same length. So we have a regular quadrilateral. Another example would be an equilateral triangle, in which all the sides are the same length. Each angle is 60 degrees, so that would be a regular triangle. You can have regular hexagons and so on and so forth. All the angles measure the same, all the sides measure the same, and it's convex. So those are regular polygons. So if the book said, what's the measure of each angle in this regular triangle? Well, just from the fact that it told you it's regular, you know it's going to be 60, 60, 60, because all of the angles have to be the same, and 180 divided by 3 is 60. So you want to look out for if it's regular or not. Okay, so you guys know some of these. A polygon with 4 sides is called a quadrilateral, right? Quad referring to 4 sides. This one would be a triangle. Okay, what about one with 5 sides? Hopefully you remember that's called a pentagon. One with 6 sides, which I'm always not very good at drawing. That would be a hexagon. Okay, those are the ones most people are pretty familiar with. Okay, 7-sided polygon is a heptagon. Okay, 8 sides, most people know this, an octagon. Think of an octopus. 9 starts with the same letter, a nonagon. 10 sides is a decagon. Okay, so if you have a 10-sided shape, polygon, that's going to be a decagon. Deca is many times refers to 10, so you can remember it that way. Okay, like a decade is a period of 10 years. 11 sides is an undecagon. Okay, it's almost a decagon, but not quite. It has 11, so it's an undecagon. 12 sides is a dodecagon. Okay, and then 13 and onward, you just put the number and then gon. So a 13-sided figure would be a 13gon, 14 gon, 15 gon, 16 gon, 17 gon, so on and so forth. All right, so after 12, just the number dash and then gon. Okay, now after we go over this lesson, you're going to take a Kahoot quiz over these terms. So make sure that you know triangle through dodecagon. Okay, some other terms we need to know about polygons are diagonals. Okay, middle of page 349. A diagonal of a polygon is a line segment that connects two non-consecutive vertices. We can name a polygon by listing the vertices in order. These polygons are quadrilaterals, MPRQ, and I changed this one. This one's A, B, C, D, E. Okay, so when you name a polygon, you have to go in a specific order. So you can start at any letter. So I could name this QMPR, and that would be fine, or I can name it RQMP, but wherever you start, you have to go in a specific order. Okay, so I couldn't name it RMPQ. No, I could do RQMP or RPMQ. Okay, but whatever I'm naming it, I should be going all the way around from one point to another. Okay, so diagonals go from one vertex to another, but not a consecutive vertex. So not from here to here and not from here to here. Okay, so in this shape here, you could draw a diagonal going from this vertex to this vertex, M to R. You could also draw one going from P to Q, but you can't draw any more diagonals because M to P wouldn't work, P to R wouldn't work, R to Q wouldn't work, Q to M wouldn't work. Those are just sides. Okay, so you can go from P to Q and M to R. That's it. Okay, some people like to go, oh, I can do a diagonal right here. No, diagonals go from one vertex to another, not just any point on the side. So you can only go from a corner to a corner. So how many diagonals could be drawn on this figure here? Okay, let's take a look. Let's see, we can do 1, 2, 3, 4, 5. Can we do any more? Doesn't look like it. So we can get 5 here on this pentagon. B to E, B to D, back and forth. A to C, A to D, back and forth. Okay, so always look for how many diagonals you can get. Okay, naming polygons and diagonals. So if you were going to name one of these, then let's just say I was going to name BE. You could name it BE or EB. Okay, so on and so forth. DA, AD, AC. Okay, so that would be how you would name the diagonals. Okay, now we have some different kinds of polygons. All right, so hopefully you remember what parallel means. Okay, if you have parallel lines, that means you have two lines, okay, that are both straight and they are parallel to each other, meaning they will never cross as they go on into infinity. Okay, so lines that will cross, and here they're not crossing, but they are here. Okay, those are not parallel. Eventually they're going to cross over, but these lines here, these are parallel. So we use parallel lines to name polygons. Okay, so a trapezoid is a quadrilateral, so it has 4 sides, and it has 2 parallel sides. one pair of parallel sides. Okay, so this shape right here is a trapezoid. We've got 4 sides, 1, 2, 3, 4, and we have one pair of parallel sides. We have a parallel side here and here. These sides are not parallel, okay? If we were to make them keep going, they would eventually cross. Okay, so this shape is a trapezoid. Okay, so remember, a trapezoid is a quadrilateral with one pair of parallel sides. A parallelogram is a quadrilateral with 2 pairs of parallel sides. Okay, so we have 2 examples here. These 2 lines are parallel, so that's a pair of parallel sides. They're never going to cross. And these 2 lines are parallel. Another pair. These are never going to cross either. So we have 2 pairs of parallel lines, and so this shape is a parallelogram. So again, a parallelogram is a quadrilateral with 2 pairs of parallel lines. A trapezoid is a quadrilateral with 1 pair of parallel lines. Okay. A rectangle is a type of parallelogram in which all the angles measure 90 degrees. Okay, so right here we have a rectangle. This is what you usually think of when you think of a rectangle. We have 2 pairs of parallel sides, one here, one here. And so this is a parallelogram, but we also have 4 90-degree angles. So not only is it a parallelogram, but it's a rectangle, which is more specific. Right here, this is a parallelogram, but we have acute and obtuse angles. So it's not a rectangle. So this is a parallelogram and a rectangle. Okay, a rhombus is a parallelogram that has 4 sides of equal length. Okay, so a rhombus has 2 pairs of parallel sides, like we have here. Okay, and the 4 sides are all the same length. Okay, so this is a rhombus. All right, so a rhombus does not necessarily have to have 90-degree angles. You just have to have 2 pairs of parallel sides, so it has to be a parallelogram. And each side has to be the same length. Okay, so it can be slanted like this. Now a square is a rhombus in which all the angles have a measure of 90 degrees. Okay, so a square has 2 pairs of parallel sides. So a square is a parallelogram, right? Has 2 pairs of parallel sides. A square is also a rhombus because a rhombus is a parallelogram in which all the sides measure the same length, and a square, all the sides measure the same length. But a square is also a rectangle because a rectangle is a parallelogram that has 4 90-degree angles. So a square is a rectangle, a rhombus, and a parallelogram. Okay, so a square could identify as a couple different things. Okay, so just make sure you know the differences. Again, trapezoids, 1 pair of parallel sides. Parallelogram, 2 pairs of parallel sides. Rectangle, parallelogram with 90-degree angles. Rhombus, parallelogram with the same length of sides. Square, rhombus, same length of sides, and rectangle, 90 degrees. So it's a specific kind of parallelogram. Okay, so those are polygons. Second part of the lesson is over congruence. All right, look at page 350, okay? Read along as I'm reading this out loud. Page 350. Consider this dialogue. Tom said, "Those 2 line segments are equal." Janice replied, "No, they are not. Only numbers can be equal. What you mean to say is that the number that describes the length of one segment equals the number that describes the length of the other segment." Tom then said, "But you will agree that those 2 triangles are equal." Janice replied, "No, they are not. The numbers that describe the lengths of the sides in one triangle equal the numbers that describe the lengths of the sides in the other triangle. Also, the numbers that describe the measures of the angle opposite the pairs of equal sides are also equal. We use the word congruent to mean geometrically equal." Janice is correct because congruent means geometrically equal, except for position and orientation. If 2 geometric figures are congruent, then all corresponding measures of the figures are equal. Congruent is a term that is often used in geometry. In trigonometry and in other branches of mathematics, we find it convenient to speak of equal angles and equal segments. When we do this, it is understood that we mean that the measures of the angles are equal and that the lengths of the segments are equal. All right, so when we're dealing with figures that are congruent, okay, the angles are exactly the same, the sides are the same length, the shapes are the same size. Okay, so right here I have 3 triangles that are congruent. Okay, now remember the difference between congruent and similar. Okay, when you have 2 similar triangles, you just have to have the same measures of the angles. The sides only have to correspond, so one can be much bigger than the other. Okay, but when they're congruent, they have to be the same size. So they have to be exactly the same, they just don't have to be in the same position. Okay, so these 3 triangles are congruent, okay? They're all the exact same size, they have the same lengths. The only thing is they are in different positions, right? This one's kind of slanted, this one's almost straight, and this one's kind of the opposite of this one, okay? But they're all congruent. They're the same triangle, just in different positions, okay? So when we move congruent triangles to get them on top of each other, then we use these things called translation, reflection, and rotation. Okay, so let's just say that I wanted to get this triangle on top of this triangle. So I'm going to use my cutout here. Okay, now there are 3 movements you can do here. Okay, there's translation. Translation is just sliding the triangle around. Okay, there's rotation, which is where the triangle doesn't move from this position, it just rotates around the position. Okay, so it stays in the same spot, it's just rotating in a circle. Okay, so usually there's an origin, so let's just say that this vertex is the origin, and we just rotate the shape around that origin. Okay, so that's rotation. So translation, moving it around, rotation, rotating it about an origin. And then there's reflection. Okay, now reflection is where you reflect it just like you would a mirror. Okay, so if I have this here and I reflect it, I'm just going to flip it over to the other side. Okay, you can also reflect it down. You could reflect it up. Okay, you could reflect it this way. Okay, so reflection is creating a mirror image. Okay, so if I wanted to get this triangle on top of this triangle, I would have to do a couple things. First, I would have to do a rotation because I need to get it in the same position. Then I would have to do a translation. I would have to slide it up on top of this one. Okay. Now, let's say I wanted to get this triangle on top of this triangle. Okay. Again, I would have to do a rotation, and then I would have to do a translation. Okay, so I didn't have to do any reflections for this one, but sometimes you would have to do that. Okay, so again, a reflection is where you would have to flip it. All right, so that's everything in this lesson. Okay, you're not going to do the practice problems for this lesson. What you're going to do is I've set up a Kahoot quiz. Everybody's going to take it. The 7th graders are going to take it too because they've already gone over these topics this year, so they should be fine. Everybody's going to take it, and we will see who does the best job, okay? Now, you're timed for each question, so you don't want to take all day, but you should have plenty of time to answer them. Okay, the rest of the information about the Kahoot should be in your packet that I sent home, but don't worry about the practice problems. If you want to get started on your lesson right now, you can. Or if you want to review and take the Kahoot quiz, obviously don't use your book for the Kahoot quiz. Try to do it without looking. Okay, it kind of defeats the purpose if you're not actually doing it from memory. Okay, so go ahead and do whatever suits you.